Welcome, cosmic explorers, to a journey into the heart of the unimaginably vast. Today, we delve into the secrets of Stephenson 218, a star so colossal it challenges our very understanding of size and scale in the universe. Prepare to have your perceptions of stellar giants forever altered. When we think of massive stars, our own sun often serves as a primary reference point, a celestial beacon central to our solar system, powering life on Earth. But the sun, magnificent as it is, pales in comparison to the true behemoths lurking in the galactic void. Stephenson 218 is one such titan, a star that redefines the very concept of large. Located in the constellation Scutum, Stephenson 218 is an enigmatic red supergiant. Its exact distance from Earth has been a subject of ongoing scientific debate, but current estimates place it approximately 18,900 light-years away. To put that into perspective, if you were to travel at the speed of light, it would still take you nearly 19 millennia to reach its fiery embrace. The Stephenson 2 part of its name refers to the open cluster where it resides, a congregation of young, massive stars. The 18 simply denotes its specific designation within that cluster. This cluster, also known as RSGC2, is a veritable nursery of colossal stars. But even among these giants, Stephenson 218 stands out as an absolute monarch. So how big are we really talking? Let's try to wrap our minds around the numbers. The radius of Stephenson 218 is estimated to be around 2,150 times that of our Sun. Let that sink in for a moment. 2,150 times bigger. If our Sun were a small marble, Stephenson 218 would be a sphere nearly 70 feet in diameter. To illustrate its scale even further, imagine placing Stephenson 218 at the center of our solar system. Its outer layers would extend far beyond the orbit of Saturn, possibly even approaching the orbit of Uranus. Planets like Mercury, Venus, Earth, and Mars would all be engulfed, consumed by its vast, fiery expanse. Even Jupiter, the largest planet in our solar system, would be a mere speck lost within its colossal volume. The volume of Stephenson 218 is truly mind-boggling. It's estimated to be about 10 billion times the volume of our Sun. To fill Stephenson 218 with material equivalent to our Sun, you would need 10 billion suns. This is not just a big star, it's a cosmic leviathan, a true titan among stellar objects. Such immense size naturally comes with extreme luminosity. Stephenson 218 shines with a staggering brightness, radiating hundreds of thousands, if not millions of times more energy than our Sun. Despite its distance, if it weren't for the interstellar dust and gas obscuring our view, it would be a visible beacon in our night sky, a stark reminder of the universe's incredible power. The classification red supergiant gives us clues about its nature. These stars are in a relatively late stage of their stellar evolution. After exhausting the hydrogen fuel in their core, they expand dramatically, cool down, and become significantly redder. They are typically among the largest and most luminous stars in the universe. Stephenson 218, like all red supergiants, is not a stable, serene object. Its outer layers are constantly expanding and contracting, a process known as pulsation. These pulsations can cause its brightness to vary over time, though these changes are often subtle and require precise instrumentation to detect from Earth. The extreme size of Stephenson 218 presents significant challenges for astronomers trying to accurately measure its properties. Its atmosphere is incredibly diffuse, making it difficult to define a precise surface. Imagine trying to measure the exact edge of a cloud that's thousands of times larger than Earth. It's a similar, albeit far more complex, challenge. One of the primary methods used to estimate its size involves studying its effective temperature and luminosity. By analyzing the light it emits, scientists can infer its surface temperature. Combining this with its overall brightness, they can then calculate its radius using fundamental stellar physics equations. However, these calculations are often subject to significant uncertainties, particularly for stars as distant and shrouded in dust as Stephenson 218. Different models and observational techniques can lead to slightly varying estimates for its radius and luminosity. This is why you might sometimes hear slightly different figures for its size from various sources. The sheer mass of Stephenson 218 is also a subject of intense interest. While red supergiants are enormous in volume, their density is relatively low compared to other types of stars. Nevertheless, Stephenson 218 likely started its life as a star with an initial mass many tens of times that of our Sun, perhaps even exceeding 40 or 50 solar masses. Such massive stars live fast and die young in cosmic terms. Their immense gravitational pressure forces their nuclear fusion reactions to proceed at an incredibly rapid pace, consuming their fuel much quicker than smaller stars like our Sun. While our Sun is expected to live for about 10 billion years, stars like Stephenson 218 might only exist for a few million years. The eventual fate of Stephenson 218, like all red supergiants, will be nothing short of spectacular. It will ultimately exhaust its nuclear fuel, leading to a catastrophic gravitational collapse of its core. This will trigger one of the most powerful explosions in the universe, a Type II Supernova. A supernova explosion of a star like Stephenson 218 would briefly outshine an entire galaxy, releasing an unimaginable amount of energy and scattering heavy elements forged in its core across the cosmos. These elements, including carbon, oxygen, iron, and many others, are the building blocks for new stars, planets, and even life itself. After the supernova, what remains of Stephenson 218 will depend on its initial core mass. If its core is massive enough, it will collapse further to form a stellar mass black hole, a region of space-time where gravity is so intense that nothing, not even light, can escape. If not, it might form an incredibly dense neutron star. The study of stars like Stephenson 218 is crucial for astronomers to understand the processes of stellar evolution, the formation of elements, and the dynamics of star clusters. These cosmic titans are not just curiosities. They are fundamental drivers of galactic evolution, shaping the universe we observe. The cluster Stephenson 2, or RSGC2, is a relatively young cluster, estimated to be only about 14 to 20 million years old. The presence of so many massive, evolved stars like Stephenson 218 within such a young cluster tells us about the intense star formation activity that occurred there in the recent cosmic past. These clusters are often found in the spiral arms of galaxies, regions where interstellar gas and dust are compressed, triggering the collapse of molecular clouds and the birth of new stars. The Stephenson 2 cluster is located in one of the Milky Way's inner spiral arms. The immense gravitational pull of Stephenson 218 and its cluster companions influences their surroundings, affecting gas and dust dynamics. What's fascinating is that despite its extreme size and luminosity, Stephenson 218 isn't easily visible due to heavy obscuration by interstellar dust. This dust blocks visible light, but infrared light can penetrate it effectively. Therefore, much of what we know comes from infrared telescopes like the Spitzer Space Telescope. These observations reveal the star's temperature, luminosity, and spectral type, and provide crucial clues about its chemical composition and evolutionary stage. The existence of Stephenson 218 pushes the boundaries of our stellar evolution models, forcing us to refine our understanding of the physics governing these massive objects. As technology advances, especially with telescopes like the James Webb Space Telescope, JWST, our ability to study this cosmic titan will only improve, leading to more precise measurements of its size, mass, and composition. The very existence of Stephenson 218 is a humbling reminder of the vastness and diversity of the cosmos. So, the next time you gaze up, remember Stephenson 218, the red supergiant that dwarfs our sun beyond imagination. It's a symbol of the universe's awe-inspiring scale. Keep looking up, keep exploring, and keep marveling at the cosmic symphony. Thank you for joining us. If you enjoyed this, please like, subscribe Science Miggy, and hit the notification bell. Until next time, keep your eyes on the stars.